Bismillahirrahmanirrahim. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. Alhamdulillah. Now we enter to the chapter 8, chapter 8 for the foundation, about the foundation. So this is for the introduction of the foundations. Okay. What is a foundation system? The foundation is the building element which distribute and transmit the building load to the earth. This is the main function of the foundation. So we go to the next slide. So to understand the function of the foundation here, okay, so this is illustration about the how the foundation is work. So now this is building. From building we'll come up with the loads. This is building loads. Okay, building load will be transferred to the foundation. Okay, when load transfer, when a load receive load, when the foundation receive the building load, the settlement will be occur. The settlement will be occur. So you need to remember here, we cannot avoid from settlement occur. We can avoid settlements occur, but we can control the settlement value when we compare the allowable value of the settlement, which is 25 mm. Okay, so we need to make sure we need to design the foundation and make sure the settlement not exceed than 25 mm. So this is soil bearing capacity. This is soil bearing capacity or existing soil bearing capacity here. So we have the strength of the soil. Okay, different soil, different bearing capacity. Okay, different that we have different bearing capacity. So that's why we need to before the construction process, we need to investigate. We need to investigate the soil stratum layer, the soil stratum layer, to decide whether we want to use the shallow foundation or deep foundations. This is two category of the foundations. First is shallow foundation and second is deep foundation. Okay, this is quiz. Okay, this quiz is good for you can imagine the basic concept of the foundations, the basic concept of the foundation. So now we have the case here. So 600 Newton. Okay, this is load from buildings to transfer to the earth. This is earth. Okay, so this is parameter of the soil. We have the friction angle equal to 0 and then cohesion equal to 35 kilonewton per meter square. Then so the question is it that soil can support 600 newtons of the load or not? Can support or not? So this is very easy. This is very easy. You can imagine here. This is the unit is Newton. This is unit kilonewton. So big than Newton. Okay. So basically the soil can support that load because 600 Newton is more than 35 kilonewtons per meter square. It's not divided for the area. This is maybe this is point load. This is point load. Although that load is small than the bearing capacity of soil, so the conclusion is that soil can support this load. Okay, this is applications of the buildings. So we can see here. Okay, low weight of the building. Okay, usually we can construct the small building with shallow foundation. Okay, with shallow foundation. Okay, for the light distribution weight, usually can use the deep foundation. This is the pi system. Okay, this is pi system. Okay, to distribute far in the soil. Okay. Alright. Okay. So this is layer of the soil layer. Okay, this is at the top is soft to firm clay, and then second layer is dense sand, and then this third layer is strong rock. So for the large distribution width, the foundation rests at the dense sand layer. So that means this system, what we call the friction pi. This is friction pi because the foundation is not rest to the strong layer, to the strong rock. Okay, for the very concentrated weight building, we need to use also deep foundation, but the foundation should be rest at the strong rock, So for this system, what we call is end bearings pi. This is end bearing pi. This is friction pi. This is friction pi. This is end bearing pi, because you receive very large concentrated weight, so we need to the pi rest at the strong rock. Okay, so the strength of the soil here is depend on the grade of the pi. Okay, because they rest at the strong rock. If pi is filled, so the load cannot support from pi cap here. This is pi cap lah. When we use the piling system, so usually they have pi cap. Okay. Alright. So okay, go to the next slide. Okay, all foundation will settle to some extent. Okay, all foundation will be settled to some extent. Okay, I was tell before, we cannot avoid from settlement occur, but we can control the settlement. We can control the settlements, whether the acid then allowable or not. Okay, for the settlement magnitude, usually less than 1 inch. 1 inch equal to 25 mm. So for the uniform settlement, acceptable if within 1 inch. And for the different settlements, the different between the foundation, acceptable, different. Okay, acceptable. Unacceptable. Okay, unacceptable if different exceed than 1 inch also. So 1 inch equal to 25 mm. So okay, what are the different load which constitute the building load? So to design the foundation process, we need consider all the whole type of the load here. First is dead load. Okay, dead load. And then second is live load, and then third is wind load. Okay, and then snow load, earth pressure, water pressure, and earthquake force. Okay, for the snow load, okay, especially for Malaysia, we not consider the snow load lah, because of the different temperature here. So, but we are concerned about the earthquake force. Okay, earthquake force, we need to consider here. Okay, so for the dead load, likes the main of the structure, namely beam, column, slab. This is considered dead load. Okay, and then for the live loads, such as humans, furniture. Okay, wind load. Okay, so load from wind lah. Okay, load from winds, so we need to refer the building code lah to use the factor of the wind loads. Okay, earth pressure, okay, water pressure, and earthquake. Okay, this is soil type, gravel, sand, silt, and clay. So the gravel and sand is category as a good material, and then although for silt, clay is a bad material. So we can classify whether the soil is bad or good by using USCS, okay, Unified Soil Classification System, okay, to classify the soil. Okay, how is bearing capacity of the soil determined? How we can determine the bearing capacity of the soil? Okay, at the site. First, we can refer the building code. Okay, which is a building code can provide minimum value that can be used for some structure. And then second, we go to the site, and then we can perform the subsurface explorations. Okay, subsurface exploration usually divide by two. First is test pit, digging a hole. So digging a hole will be what we call that. Usually can use the wide area to do this procedure. Okay, why for the test bearing? Test bearing is not used. It is not used for the wide area, because we use the hollow auger to digging the hole, and then we can take sample to test at the laboratory to get the parameter of the soil to help in the design process. Okay, this is soil sample. First, when we get the soil sample, we need to classify the soil, whether they are good or bad, the material or not. So, and then second is properties determined, like density, moisture content, acacia strength, void ratio, bearing capacity, liquid and plastic limit, and also plasticity index. This is basics parameter that compulsory to know to come up with the good design of the foundation. Okay, this is geotechnical investigation or explorations. So we need to refer the logbook reports. Okay, usually the logbook reports contains first consists first site investigation. Okay, second is lab investigation. Third is site conditions, and then engineering analysis and recommendation, site grading and earthworks, footings and slab on grade, and then lateral pressure. Okay, moisture protection and subsurface drainage, and then paving. So this is example of the bearing log. So this is type of the soil here. We can determine by using chart. By using the chart. Okay, this is calorimetric features that we need to consider against. Okay, because different of the calorimetric features will be produce the different problem. Okay, so first is frost line. Okay, the different temperature will be okay, like the cool temperature. So they can produce the frost line. Okay, frost line will be come up with more problematic for the construction. Okay, also expensive soil will be the soil will be expand because of the high water table. Okay, and the soil will be shrinkage because of the lowest of groundwater table. So okay, groundwater, okay, and also hydrostatic pressure. Okay, this is soil treated by using PVD. Treated by using PVD. What we call fabricated vertical drains. Okay, before we construct, proceed with the others. What we call it construction of foundation, we need to treat the soil. Okay, we need to flow up the water from the soil to treat that soil, to confirm that soil is to avoid from excessive settlement. So we can treat with fabricated vertical drain. So this is shallow foundation. Okay, this is schematic of the shallow foundation. Usually we can differentiate between what is difference between deep and shallow. Okay, the definition of the shallow foundation is the foundation is not the depth is not greater than 3 meter. Okay, if greater than 3 meter, we consider as a deep foundation. So this means for the shallow foundation, the depth of the foundation should be low than 3 meter. Okay, shallow foundations. Okay, what is function of the shallow foundation? Actually, the function is transport building load at or near soil surface. At or near soil surface. This is function for shallow foundation. So we have the type of the shallow foundation. First, footing. So footing, we have the column or single footings, and then we have the strip or spread, and then wall, and then combine. So okay, and then the second type of the shallow foundation, slab. So we have the several type here. Slab on grade, slab cross space, and then basement. And then the third is mat or rough foundation. So this is type of the shallow foundation. So this is column footing. So column footing. So also we can call is pad footing. Okay. So this is combined footing. The combined footing. This means the foundation is receive more than one column. Okay, more than one column. So this means what we call that combined footing. Okay. So for the cantilever footing or strap footing, the foundation is receive more than 2 column. Okay, receive more than 2 columns. So what we call the cantilever footing, and then this is wall footing. So okay, this is spread footing, shape and dimension. So we have the square footing, we have rectangle footing, we have continuous footing, circular, combined and ring. Okay, so this is shallow foundations. How the shallow foundation is work. So this is plan. This is single column footing. This is downward column load. Okay, this is load from building. Okay, transfer to the foundation. When load transfer to the foundation will be bending. Will be bending because of the load. Load from building. So that's why at the top here is going to be compression. Okay, this is going to be compression, and then at the bottom is going to be tension. So that's why to avoid from foundation failure, we need to put the soil reinforcement. We need to put the reinforcing steel bar or reinforcement. Okay, to resist the tension cause of bending. Okay, this is outward soil pressure. Okay. Okay, this is example for the combined footing. Example of the combined footing. Okay, this is example for slab on grade. Okay, slab on grade. Okay, this also for slab on grade. Okay, this is example for cross space. Okay, this is example for basement, substructure of basement. This is the worker busy to install the reinforcement of basements and also install the what we call it formwork. So okay, this is also for the basements. Okay, basement. Okay, this for the construct the basement, we need to consider several factors like this is the ground lanes, this is groundwater lane. Okay, this is hydrostatic. We need to consider the hydrostatic pressure on wall and slab below ground water, okay, at the side and also the below. So when we have the water table here, so the hydrostatic pressure will be produced here. So we need when we design the basement, we need to consider the hydrostatic pressure. Okay. So this is basement. As you can see here, this is the membranes to avoid from water penetrate to the wall. Okay, this is map or rough foundations. Okay, like slab. This is like slab. Okay, building construct on the slab or rough foundation. So this is concrete slab. Okay, this is concrete slab. So this is layer of the concrete slab. Okay. So as you can see here, this is reinforcing bar. Okay, it connect with the ground beam. So this what we call the suspended slab. Okay, this column footing. So you can see here, this is at the center of the footing. We can construct the column footing or stump, what I call the stump here. Okay, footing foundation wall. This is foundation wall. Okay, for example, for the foundation wall. So this is also for the foundation wall. Okay, to construct the foundation wall, we need to excavate. They need to excavate first to easy conduct the constructions, to easy install the formwork and also construct the foundation wall. Okay, and then we can put the perforated pipe here to drain out water. Okay, from deck soil, from soil here. Okay, this is slab, this is footing, this is concrete wall. So okay, this is also for the wall footing. Okay, this is the location of the pipe. This is drain mat. Okay, drain mat. Okay, this is waterproof. Okay, waterproof. And then this is reinforced concrete footing. So I think that's all for today. So we can see you again for the next session. Okay, for today is enough. So wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.